All right. So today, relations and functions. So a set of ordered pairs. That's all that a relation is. It can be shown in several different ways. One way is how we're used to seeing that, and that's a table. Y'all remember the tables that had x and y values like that? That's what a table looks like. And then we can have a mapping. We'll look at some of those in just a moment. Those are bubble pictures. A graph, or it can be expressed as an equation, which we'll spend a little bit more time on tomorrow. So all of those different ways of showing a set of ordered pairs. So tables, mappings, graphs, equations are all ways of doing that. Set of the x values is called the domain. And that's going to be a big focus today. Pretty big focus for the rest of the semester. Spend a lot of time talking about domain. And then the set of all the y values is called, does anybody remember? The range. Very good. The range. And so we're looking at a graph of a set of ordered pairs. The domain is just going to be the x values. If it's listed in a table, that's really easy. They're all just the ones that they list. But when we look at a graph, there's a little bit more involved. Range is the up and down. And when we read the domain, we want to read left to right. When we read the range, we want to read bottom to top, because that puts numbers in the right order. Okay, so that's how we'll kind of mention that as we go along throughout there. A relation with distinct points is called discrete. And what that means is you don't have a continuous line. You have individual ordered pairs. That's discrete. Discrete things are separated. It doesn't connect. And then a relation with connected lines or curves is called continuous. Continuous is just as it says, connected lines, or it doesn't have to be necessarily a straight line. We get further in semester, we'll get into more curved lines and things out of that. So next little box is talking about functions. So a function is a special type of relation. A relation is just a set of ordered pairs. So it doesn't take much other than just list to be a relation. But to be a function, you have to have some special qualities. And a relation is each element of the domain, so that means what values are domain values? X values are paired with exactly one element of the range. Range is what? Y value. So each X is paired with one Y. So an example of a function might be this set of ordered pairs. That's a good set of ordered pairs. In that set of ordered pairs, notice that no x value is repeated. That's what this statement there is really saying. No repeated x values. So to be a function, you cannot repeat x values. That's the whole thing you need to remember about determining if something is a function or not. Do the x values repeat? If they do, then it's not a function. If the x values don't repeat, like this example we've got here, no repeated x values, then that is a function. It's okay to repeat y values and be a function. So y values repeating is not a problem. It's the x values that repeat that's the problem. Here's an example of one that's not a function. So set of ordered pairs like -7, 2, 6, -1, 6, 2, -3, 9. That one is not because of the repeated 6 x value. That's all it takes to make it be not a function. is a repetition of an x value. Notice that that one also has repeated y values, but that doesn't affect whether or not it's a function. So x's cannot be repeated. My wife and I kind of laugh about this line, and then we both use it when we teach that if you want to function properly, don't repeat your x's. And that's good dating advice and good, helps you to learn things. So maybe you'll remember it that way. So we kind of chuckle at that when we teach this particular topic. So, all right. Now, if you got a list of ordered pairs, that's what you're looking for. Look at the x values. Do any of them repeat? If they do, it's not a function. If they don't, it is a function. What happens when we have a graph, we've got to be a little bit more careful. And there's a test that we can use. It's called the vertical line test. So you got that little box there. It talks about the vertical line test. In order to be a function, a vertical line cannot pass through more than one point in the relation. So a relation could be a set of ordered pairs. It could be dots here, or it could be a graph like drawn. So if it's a graph that's drawn, maybe it's this picture, a nice line. Did a lot in Algebra 1 with lines. You do a decent amount with it in geometry, so that's something we're pretty familiar with. So that is a function because there's nowhere that I can take a vertical line. If I drop that vertical line on it, how many times does the red line hit the blue line? Once. If I pick that one up and I pick another spot to drop the vertical line, how many times does that red line hit the blue line? One time. No matter where I put that, it can only hit it once. So that passes the vertical line test. So this one would be a function. Here's an example of one that's not a function. And that might be something like this sideways curve here. You remember from Algebra 1, that's a parabola, but it's turned sideways out of that. So that one fails the vertical line test because if I drop a vertical line, it hits it in two places. Those two places have the same x value, but different y values, and you can't repeat x's. So that's why that vertical line test works. That when you drop that vertical line, if it hits twice, then those are the same x values, but with different y values. So this one is an example of one that's not a function. So if you've got a graph, the vertical line test really is the best thing, and it's a quick test. You can just take your straight edge or your pencil and lay it up on that graph and just kind of stretch it across there. If it touches more than once at any spot, then it fails. If it only touches once everywhere you put it, then it passes and it is a function. So really, really easy thing there that you should have seen before. All right, so let's look at some examples of defining out the domain and the range of a relation and then deciding if it's a function or not. So domain and range can be found whether they're functions or not. Just because a relation isn't a function doesn't mean it doesn't have a domain, it doesn't have a range. Domain is just the set of the x values. Range is just the set of the y values. Whether or not it's a function is dependent upon some special case with the x's. So let's look at this one, and let's list the domain for that set of ordered pairs on number 1 there. So you got -1, -9, 0, -5, 4, 3, and 6, -2. So when we list the domain, we use a set notation. So we use a little curly brace. It's the same. I'm trying to draw the same thing that they've got there. That's the same symbol I'm trying to draw. And then I'm just listing the x values. If one repeats, only list it once. Okay, so this one doesn't have any repeats on the x's. So I'm just going to list them. And I tend to list them in numerical order. That's not a rule that you have to. I just do that because it makes my brain not hurt. So putting them in order is not a necessity, but it sure does help sometimes. And then the range is the list of all the y values out of that. So the y values, the smallest one's -9, -5, -2, and 3. Again, you don't have to put them in order, but I just do because it seems to make sense to me to put them in order. Now, is that one a function or not? Yes, it doesn't repeat any x values. So yes, it is a function out of that. So super easy thing. All right. Now, number 2. Let's go over there to number 2 and look at it real quick. Domain of that function. What's the domain? Is 0 an x value? No. It's a y value. So 5. And there's a 5 again. But once I list it once, I don't have to list it again in the domain. And then the last one would be 8. And then the range is going to be the y value. So the smallest one is -6. Then we got 0, 2, and 4. I'm just putting them inside the curly braces. Is that one a function? No. Repeating. Got a repeating x value there. That 5 messes it up. Okay. Example 3 and example 4 are no different than examples 1 and 2. They just list the ordered pairs in a table. Yeah, to me it's easier to read. I don't get so confused with all the commas and things. It makes it easier for me to read. Also makes it easier for me to find the domain and range, right? Because the domain's all the left side and the range is all the right side. And that's easy to do. So domain for number 3. Yeah, -4, 0, 2, 7. And the range and 3. We only list the 3 one time there. And it is a function because no repeated x values. So again, yeah, I like the tables too. They make things easier. The x values, the domain's on the left, the range is on the right. Makes it real easy to do there. Number 4, same thing. I don't see any need in us doing another example of that. That's too easy. Let's go to number 5 because that's a mapping. It's got the bubbles. That's the mapping. That's just as easy as the table. You got one bubble is x's, one bubble is y's. So that makes it easy to get the domain and the range. So the domain is just going to be everything that's in the x bubble. So -4, -2, 5. The range is going to be everything that's in the y bubble. 0, 3, 7, and 9. They were nice and put it all in order for us on that one. And is that one a function? No, why not? Yeah, the 5 goes to the 7 and the 5 goes to the 9. So what that creates is ordered pairs. It's, -4, 0 is an ordered pair. -2, 3 is an ordered pair. 5, 7 is an ordered pair. And 5, 9 is an ordered pair. So you get all those ordered pairs from that mapping. So that one works out nice. Number 6, same idea. Is number 6 a function? Yes. Well, what's repeated? The 7's repeated, right? But it's a what kind of value? It's in the range. It's a y value, and it's okay to repeat y values, just not x values. So this one is a function. And then you could state the domain and range for that if you wanted to. Let's look at number 7. So they start throwing in these graphs, and what are those dots representing? Ordered pairs. Okay, so let's list out the ordered pairs here. So that'd be -3, 1. This would be -3, -2. 0, 1, 2, 3, 4. 2, -1. And then this one down here would be 2, 3, 4. 1, 2, 3, 4, 5. -5. So writing out those ordered pairs that are there is helpful when we're listing our domain and our range. So the domain, -3, 0, 2, and 4.